Everyone, I'm Vani, Assistant Professor, Department of Computer Science from Dr. SNS College of Arts and Science. In the last series, we have seen what is a proportion logic, what are the types of proportion, and what are the declarative sentence. And with example, in this series, we are going to see uh, what are the proof derived rules, then what are the natural reduction summary. Here, uh, we are using the proof theorem such as P implies Q implies Q implies R implies P implies R. These are the following proof statement that we have to derive. That is, we have to assume the first condition P implies Q, then the second condition Q implies R. In the third step, we have to assume P alone, and the first then we have to repeat the process for the first step. Then after repeating the process, we have to eliminate P and implies then the fifth step, we have introduced Q implies R. We will repeat the process. Then in the seventh step, we will eliminate the process. In the eighth step, we will proving P implies R, introducing. Then the next step, we are giving Q introduction, Q implies R and P implies R. And finally, we will introduce the condition, that is P implies Q, Q implies R, then P implies R. In this following method, we will use the condition introduction and the condition elimination. Through this theory, we will reduce this proof, and we will finally note that the theorem, proof that the theorem as a final one. The next one is provable equivalence. Provable equivalence is nothing but logical conditions that are equivalent to the other condition, which is denoted by the following one, that is P conditional true equivalent to P condition, then P disjunction equivalent to the P condition, which denotes the law as identity law. The next one is vice versa of the condition, then it is known as the domination law. The next one is idempotent, which denotes the same condition, such as P conjunction or disjunction P. It implies the same condition P. The next one is double negation. It implies the double negation of P must be equivalent to P. The next one is commutative law. Commutative law denotes the swapping of two variables, such as P or condition Q equivalent to Q or condition P. The same repeats in the conjunction also. P and condition Q must be equivalent to Q and condition P. These are the following swapping method of a commutative law. Next one is associative law. In this associative law, we will dividing the variables into more than two formats, such as that must be equivalent to the other one, which is known as associative law. The next one is distributive law. Distributive law is nothing but you are distributing the elements throughout the formula based on the conditions, such as P R condition Q and R must be equivalent to Q R P R Q and P R R. These are the following conditions we are implementing in this distributive law. The next one is De Morgan's law. In this De Morgan's law, we will implementing the negation condition to the whole process, so that the result will be changing according to the condition, such as negation of P conjunction Q must be equivalent to negation of P or negation of Q. Then in negation of P or condition Q, then the condition must be negation of P and negation of Q. This is known as distributive law. De Morgan's law. The next one is absorption law. It denotes the following factors, that is P, R, P and Q equivalent to P condition, or P and P or Q equal to P condition. This is known as absorption law, which changes the logical condition based on the logical operators based on the condition, where we are changing the value according to the absorption law. The next one is negation law. Negation law, we have already seen that negation of the variable must be either true or false based on the conditions. Here is an example of a contradiction. Proof by contradiction. Contradiction is nothing but we have to prove that every conditions of a formula is a false. Here is an example of a contradiction, that is P or Q and negation P and negation Q. These are the conditions we are solving in a truth table, and finally we will get the result as a false condition for all statements. The next one is propositional logic as a formal language. We will see this following propositional logic as formal language in the upcoming series. Thank you for listening to the series. Thank you.